Our recording. Okay. All right. When we covered some equations and multi-step equations, I talked to you guys about this right here, just having a consistent approach to every equation. I'm going to add one thing in there. With what we're doing today, I'm going to add one more thing into that approach, okay? We are still looking for distribution first, okay? Looking for those parentheses, okay? Or any type of grouping symbol, but typically it's parentheses, okay? Still looking for distribution. We are still going to combine like terms on both sides of that equal sign. We want this equation to be as simple as possible on both sides before we start moving stuff around, okay? Here's kind of the new part. Number 3, let's make sure we get our variables to one side or the other, left or right. Guys, it does not matter. It is completely your choice. As we do some of these, I will talk to you about a little bit of strategy, okay? But it does not matter. I've had some students before, they're like, well, I'm afraid I'm going to put it on the wrong side. There really is no such thing, okay? Number 4 then, let's get all of our constant terms to the other side. Guys, remember what a constant term is. A constant term is a number without a letter. It's a number without a variable. Okay? That's what a constant is. So variables on one side, constant terms on the other, and then it's back to kind of normal here. Do we need to add or subtract anything? Do we need to multiply or divide anything? Okay, those are kind of typical things, but as we've seen, there's always exceptions. Okay, so, but this should, again, give you some framework, give you an approach that should provide some consistency to kind of work down through as you experience these equations. Okay? Any questions there? All right? And I will kind of reiterate these as we go through some of these examples. Okay? All right. Is anybody still writing here? Can I? Okay, keep writing. I'll give you a second. It's all good. Okay, distribution, combine like terms, variables to one side or the other, constant terms to the other side, add or subtract, multiply, divide, okay? Try to have some consistency in what you're doing. Okay? Okay, close. Okay, Ellie, you good? You're still writing? Keep going. Good. Okay, here we go. Let's start right here. Start right here, guys. Okay, 5x minus 8 equals 3x plus 12. Again, there's my line. I'm going to go ahead and let that line define the left and right side of the equation. Is there distribution? Yes or no?
No.
No, there is no distribution. No sets of parentheses. There is no distribution, okay? On the left side, 5x minus 8. Can I combine those two things? Yes or no?
No.
No. On the right side, 3x plus 12. Can I combine? Bless you.
No.
No. Okay? Bless you. So there is no distribution. Bless you. I cannot combine either side of this. This equation is as simple as it's going to get at this time. Okay? So now, let's move our variables, bless you, to one side or the other. Bless you. Okay. Listen carefully. I told you guys it does not matter which side your variables go to. Okay? Now, I am a person that likes to keep my variables positive, so strategically, I tend to move the smaller one. Between 5x and 3x, which one is smaller? 5x and 3x, which variable is smaller? 3x. So typically, here's what I would do. I'm going to move the 3x from the right side to the left side. 3x is positive on the right, therefore I'm going to subtract it. I am moving the variables to the left side of the equation. The 3x's cancel on the right. 5x minus 3x is what? 2x. Notice that when I subtract 5x and 3x, it's a positive 2x. Now, that's me using a little bit of strategy. I like to try to keep that variable term positive, okay? If you want to put the variables on the right, no big deal. It is perfectly fine to go over there. I still have a minus 8 equals positive 12. Is everybody okay with that? I am moving the variables to the left. Question? Sure. Now, which term do you think we're going to move now? If the variables come to the left, what do you think we're going to move to the right now? Christian?
The 2 or the 8.
There you go. And how are we going to move that 8?
Adding 8.
Correct. Let's add 8. Let's now move the constant numbers over to the right. So now the 8's going to go to the right. We're going to add that 8 to both sides. We have isolated the variable term 2x. Now notice, variables are on the left. Constant terms are now on the right. We've got 2x equals 20. What's our solving step here? What's the last step we're going to take? Divide by? 2. Beautiful. Divide both sides by 2. And 20 divided by 2? Perfect. Good job. X equals 10. Okay? It does not matter which side you put those variables on. You just need to choose a side, move the variables to one side or the other. I chose to go left here to try to keep my variable term positive. That's why I subtracted 3x. We would get the same answer if you put the variables on the right-hand side. If you moved the 5x to the right side, guys, we would have gotten the same answer. Okay, so it does not matter. It's totally a matter of preference for you. Okay? Any questions here with this example? We okay with all this? Okay. All right. Next one. Here we go. 11 minus x equals 51 minus 6x. Is there any distribution here? There's not, is there? Okay. On the left side, 11 minus x. Can you combine those?
Nope.
Can't. On the right side, 51 minus 6x. Yes or no? Can I combine those? Are you allowed to combine a 51 and minus 6x? Nope. Okay. So again, both sides are as simple as they're going to be right now. Okay. So now here comes that decision. What side do we want our variables on? What side do you want to put the variables on? Right or left? You want to put them on the left? Okay. If we're going to put the variables on the left-hand side, which one's moving? The 6x. And how's it going to move? What kind of a 6x is it? It's negative. So in order to move it, we will need to add it. Yes. So check it out. We're going to add 6x to both sides of the equation. We are choosing to move our variables to the left-hand side. We are indeed moving the smaller of the two terms, so this should come out to be positive. So check it out. 6x's gone. Still got my 11. Guys, what's 6x minus 1x? 6x minus 1x? Beautiful, thank you. 5x, positive, equals 51. Okay, we're going to add 6x to both sides. The 6x's on the right side disappear. We have removed them. On the left side, 6x minus 1x is 5x. We still have an 11. We still have the 51 on the right. Everybody okay with that? Now, if the variables have come to the left, which one of these terms do you think is now going to move to the right? 11. And how's it going to move? Subtract it. Negative. That's right. Let's subtract 11. Here's that addition subtraction step. Boom. Gone. 5x is now by itself. We have isolated the variable term. 51 minus 11, I believe, is correct. Yeah, 40. 40. I think I heard it over there. 51 minus 11 is 40. What's that solving step? What's the last step here? Yeah, awesome. Good. 40 divided by 5, there's your 8. Okay? No distribution, no combining like terms. We got the variables on one side, constants on the other. Use that addition subtraction step there. Now there's our division step of 5. 40 divided by 5, positive 8. Love it when these answers come out to be nice, clean integer numbers. It's pretty nice. Not always the case, and that's okay. I think it's back. Did somebody take the girls' pass? Mm-hmm. Who's got it? Zyla. Oh, Zyla's got it. That's right. Okay. All right, here we go. Check it out. Progressing a little bit here. What's the first thing we're looking for? Distribution. Do we have distribution this time? Yes. Set of parentheses, right? What's the number that's going to get distributed? 3. Guys, make sure that 3 makes it to both terms with multiplication. 3 times 6x.
18x.
Perfect. 18x. 3 times negative 1. Negative 3. Got a positive times a negative. Always going to be a negative there. Positive times a negative, going to be a negative result, so negative 3. Right side, 11x minus 45. No distribution, so we're going to keep it the same. Okay. On the left side, 18x minus 3, can you combine that? Yes or no? No. 11x minus 45 on the right, yes or no? No. There you go, good, with confidence, okay? What side do you want your variables on here, right or left? It doesn't matter. What side do you want them on? You want to go left? If we're going to go left, who's moving? 11x. How's it moving? I like it. We are going to subtract 11x from both sides. Okay? Moving things from one side to the other, just moving them from one side to the other, addition, subtraction. Okay? 11x's gone. 18x minus 11x. 18 minus 11 is 7. 7x minus 3 equals negative 45. We have made the decision to move the variables to the left-hand side. Perfectly fine. Here's what we've got left. If the variables are moving to the left, guys, what's the constant term that now needs to move to the right? Well, right now it's what kind of a 3? And we're going to move it by making it a, now say it. Perfect. Let's add 3 to both sides. Boom. 7x equals, what is negative 45 plus 3? Beautiful. Negative 42. Different signs. Subtract. Take the sign of the larger number, right? Negative 42. Those darn sign numbers, guys, they're never going to go away. And what's the solving step? By? I like it. Divide both sides by 7. Negative divided by a positive, always a? And what's 42 divided by 7? Perfect. Negative 6. Negative 6. Okay? So again, some nice integer answers here. That's always good to get. I hope you're starting to kind of see and kind of feel that routine a little bit, kind of that a little bit of a pattern, if you will. This time we had some distribution, but then, hey, variables to one side, constants to the other. Okay, that's our addition subtraction stuff. And then multiply or divide to solve. Okay, it's pretty repetitive. Okay, guys, it is of the utmost importance that you stay organized on that paper, hence the line. Keep that equal sign lined up. Keep things where they're supposed to be. Kind of let them stay in their lane, so to speak. Okay? I've seen a lot of students do some good work that get lost in their own work. Okay, here we go. This might be, I think this is the last one. I think this is the last example. The last example. Love it. Love it.
How much more time do we have for class?
Pardon?
How much more time do we have?
We got a good chunk. We got an hour left.
Okay.
Got an hour. You're going to have plenty of time to settle in. Put a little bit of this to practice today. Now, I think it's pretty evident that with this example here, visually, there's a lot more going on here. There's a lot of things that you're probably seeing visually. Okay, so again, organization, more steps, write things down, take some time here. Yeah, get into that right here. Hang on. Guys, is there distribution here? How many? two distributions. Two sets of parentheses. Both of them have multipliers in front, so let's take care of that. Guys, here on the left, what is going to be distributed on the left-hand side? I like it, AJ. Negative 1. Does everybody see that? There's an understood 1 right there. It's not the 5x. That is a negative 1 that needs to be distributed there. That 5x is going to stay put. You are distributing a negative 1. What is negative 1 times positive x? Negative 1x. Good. Watch your signs here. What is negative 1 times negative 18? Positive 18. A negative times a negative is a positive. Watch your signs. One little sign mistake at this juncture right here kind of throws the rest of the problem off. So just really check those signs. Is everybody good with that? Everybody's good with this basically having a negative 1 being distributed here? Negative 1 times x, negative 1x. Negative 1 times negative 18, positive 18. Pardon? The 5, because that is 5x minus, and then that quantity x minus 18. So technically that is a negative 1 in front of those parentheses. Okay? Okay, good. Everybody okay with this? On the right side, what's getting distributed? Negative 2. You've got 6 minus 2 times x plus 15. So on the right side, the negative 2 is what's going to be distributed.
Can I use the bathroom, please?
Yes, sir. So again, guys, keep that 6 there. There are many students, listen carefully right here. This can happen to you very easily. It could happen to me very easily. There's a lot of students right here that would subtract 6 minus 2 and get a 4 and distribute the 4. Are you allowed to subtract before you multiply? Order of operations? No. No. Make sure that we are still following those order of operations. What is negative 2 times x? Perfect. Negative 2x. What is negative 2 times positive 15? Negative times a positive is a negative. And what's 2 times 15? Perfect. Negative 30. Yep, that is a 3. Sorry, it's my sloppy 3. Okay? So again, any little hiccup right here in the early stages of solving this throws the rest of the thing off. So we've really got to be checking the distribution, checking the signs. Is everybody good where all that came from? Do you have a question? No? We got big guy. Do I? Pardon? The 30 came from the negative 2 getting multiplied all the way over to the positive 15. Negative 2 times positive 15 gave us that negative 30. That was the second part of that distribution. Negative 2 times positive 15. Negative 2 times x, negative 2x, negative 2 times 15, negative 30. All right, left side of the equation. Is there anything over there that we can combine? Say again. 5x, which would be a total of what? What's 5x minus 1x? 5x minus 1x. 4x. Combine like terms. Combine like terms. 5x minus 1x is now 4x plus 18. On the right side, what can you combine? Okay, a 6, and what kind of a 30 is that? Okay, so what is 6 minus 30? Negative 24. Different signs. Subtract. Take the sign of the larger number, right? Negative 24. So this problem here, we're getting to use everything. We're distributing. We're combining like terms, okay? Each side of the equation at this point is as simple as it's going to get. What side do you want your variables on, right or left? Doesn't matter. Which one? Left. So which one's moving? How's it moving? Add 2x to both sides. 2x is on the right, gone. And guys, I've had students, and you might be this way. If you want the variables on the left-hand side all the time, that's fine. Put them on the left-hand side all the time. If that's what you're comfortable with, do it, okay? What is 4x plus 2x? 6x plus 18 equals negative 24. Variables have come to the left, so what's the constant number that probably needs to move back to the right? Well, positive 18, and the way you're going to move it, AJ, is by doing what? Thank you. Negative 18. We're going to subtract 18 from both sides. 18's gone. 6x equals. Be careful of this one. Remember this one. Negative 24 minus 18. Guys, if the signs are the same, add and keep the sign. And you are exactly right. That is a negative 42. If you add two negatives, you are going to get a negative. Negative 24 minus 18, negative 42. What's the solving step? Divide by 6. And a negative divided by a positive is a negative. And 42 divided by 6? Looky there. Negative 7. Negative 7. Okay? So that one right there, a little bit of everything. A little bit of everything. Okay? Questions there? Any questions on that particular example? Okay. Everybody got that one down? Yellow. Yep. Hey, welcome back. Okay. Now, kind of similar to what we did the other day. Wednesday, we're going to do a little bit more of the same. I will roll in Wednesday a couple of special cases. So we won't really be doing a whole new lesson, but we're going to kind of expand on this lesson on Wednesday with some specialty stuff. As far as today, what do you want to do? Odds or evens? Evens. You want to do evens? Okay. So, and let me double check to make sure I hit the publish button this time, but we are going to do the evens then, okay? Odds or evens, I think that's going to be 6 whole problems. Can we accomplish 6? Can we accomplish 6?
Can you put it back on the slide, even for the problem?
Yep. Let me go ahead and I believe that should be, it's going to end up being